12-inch wire is cut at a position X measured in inches from the left end of the wire, where 0 is less than X is less than 12. The left-hand piece of the wire is bent into a circle and the right-hand piece is bent into a square. Write the sum of the areas of the circle and the square as a function of X and determine the value of X that minimizes the sum of the areas. So let's say that this is the 12-inch piece of wire right here, so it's probably worth labeling this end as 0 and this end is 12, measured in inches. And I'm going to find some position X, say right here, where this thing is going to get split. So there's the position X, and notice that gives me this length right here being X, and this length right here is 12 minus X. Now, the first piece on the left here gets bent into a circle, and this is going to be kind of a larger circle that it will get bent into. And this smaller piece over here gets bent into a square because I didn't give it much wire. That will be a much smaller square. And what we'd like to do is we would like to write the area. We'll write that function. We'll call that function a of x. The area of the circle plus the area of the square as a function of the position x where we actually split the wire. So first thing I'm going to do is I'm going to write down the equation for the circumference of a circle, and that circumference is 2 pi r, and I know that circumference is going to be x. The reason I know that is I've given x total length to the circle. I have wrapped it around in this fashion, so its circumference has to be x, which means we can solve for r. The radius r in this case will be found by dividing both sides of that equation by 2 pi. When you divide the left-hand side by 2 pi, you get r. When you divide the right-hand side by 2 pi, you get x divided by 2 pi. Now let's go to the square. So for the square, we know that what we have done is we have taken this length right here of the wire, and we have bent it into 4 pieces here. So what we have is we have the equation 4 times s is the total 12 minus x, where s is the length of one of the sides, just as in the previous situation we had r as the radius of the circle. So to solve this function right here for the side length s, all we need to do is divide both sides by 4. When you divide the left-hand side by 4, you get s. When you divide the right-hand side by 4, you get 12 minus x divided by 4. Now, at this point, what we're going to do is we're going to try to write the function for the area. If we know the radius of the circle is this, then what is going to be the area? Well, the formula for the area is pi times the radius, and we know the radius is x over 2 pi squared. Now on to the square. We want to add in the area of the square, and if we know that the side length here, s, is 12 minus x over 4, in order to get the area of that square, what we need to do is we need to take 12 minus x divided by 4 and multiply it by itself, which is the same as squaring it. So now what we have is we do have the total area written as a function of x, and it's probably worth simplifying here a little bit. So let me box these to get them out of the way. And this a of x will be equal to pi multiplied by x squared over 4 pi squared. And over here, we can multiply out the numerator and the denominator over here in this case. So when you multiply out the numerator, you're going to get 12 squared, which is 144, minus 24x plus x squared. And the denominator, when you square it out, will be 16. Notice that this pi will cancel with one of those pi's. So what we have here is x squared divided by 4 pi plus, and for these terms I'll reverse their order because we tend to put the higher order terms first. This will be x squared over 16 minus 24/16 x plus 144 over 16. You will recognize this as a quadratic. We have an x squared term, and then we have a linear term, and then we have a constant term. So in terms of what is the coefficient of the x squared term, that is going to be 1 over 4 pi plus 1 over 16 multiplied by x squared. When you look at 24/16, both of those are divisible by 8. So when you divide 8 into 24, you get 3. When you divide 8 into 16, you get 2. So you get minus 3/2 x. And finally, the last piece here is 144 divided by 16. 16 goes evenly into 144, and that is equal to 9. So there is your quadratic equation, and you can think of that as a x squared plus b times x plus c. And we see now that the sum of the area of the circle plus the area of the square is a quadratic function. And furthermore, because this coefficient out front of x squared is positive, it is a concave up parabola. So if I were to draw a quick sketch of this for x values between 0 and 12, because 0 and 12 are the two limits with where I can break the wire, you're going to have a parabola that is concave up. In other words, somewhere, and we're not sure where, it is going to achieve a minimum. And the way you find that minimum is if you look in the formulas, you will see that negative b divided by 2a is where that minimum occurs. So in this particular equation, your negative b is going to be 3/2. That's up in the numerator. And your 2 times a is this quantity right here. So we have 2 times 1 over 4 pi plus 1/16. Now if you take that number and you plug it into a calculator, the number you get is 5.2788, and that number right there is the solution to the problem, where it is asking what is the value of x that minimizes the function. This is 5.2788. I'll just write that as 5.28 is this point, which will give you the smallest sum of the area of the circle plus the area of the square.